Hey yo, welcome. Sorry that I'm a few minutes late. I had to preemptively get some darkness fending off supplies. Now, there's always good old lantern. Well, of course, people often bring up a porch light or something, but no, there's no light on the exterior of the house right here. So there's always good old lanterns and stuff, which would be a good idea. But there's always older candles. So luckily, I already designed, kind of unintentionally, didn't even realize until I was doing it how perfectly it would be for candle holding, some gourd based candle holders. So we can use berries to make a nice little lantern combination with some wax and some wicks. Hello to everyone who is rolling through. I love all of you combo lords. And let me light up this scene with a little introductory chat before I go through many comments. So feel free to drop any questions or thoughts. But for now, I'm just going to light a little fire and reminisce on all of the good candles I've lit in the past. Campfires as well, just having a good old fire on its own, as long as you're very safe with it, can be a nice way to light up the darkness. And in fact, today could be possibly the first day that I end up bringing you guys inside my room for a stream later, because I don't know how long this candle deal is going to work out. It might rain in a bit. And although the candles are good against the darkness, they're going to be nothing compared to the rain. So I brought out an umbrella just in case we get a tiny sprinkle, but if it starts going much, we may visit my room for the first time, but I think it's about time to write some equations on my room walls anyway. So, and I already had to put some clocks from here in my room for the rain protection for some of the more fragile clocks. So there's already clocks in there too. So we'll be pretty set if we need to take a stroll inside there. But for now, hope everyone's having a wonderful night or day or wherever it is. It's a bit rainy here today, and I had some lessons to teach and various little things to do, but still managed to get some fun little filming and writing in as usual. Now I'm going to need to get some wind protection, it seems like. And as many of you may be aware, we have oh man, this is not working. We have skyrocketed up in amount of subscribers around here, and all of you have probably been here varying amounts, but anyone who says they were subscribed to this channel um, 3 months ago or more is lying, because this channel hasn't even existed 3 months. Um, Although some of the footage I've been filming for it was since April, and some of the footage for the main channel started right at the end of last year. In fact, it was probably not long after this point last year that I first bought the big whiteboard. Before I had any of the small ones, in fact. I got a big one because I knew it would come in handy. And boy, has it already come in handy. And now it is getting some dents and some paint marks and stuff. But with that said, it can wait until grade -2 to get replaced, and we are just in the second half of grade -1. And it's a little hard to gauge when it'll feel exactly the right time to transition grades, but I would expect that we're somewhere around 60 or 70% of the way through grade -1 right now. Now, raining at someone else's house in the comments as well. Yeah, it's been raining on and off here, but I live in Berkeley, California, and the weather's usually pretty decent, like doesn't get too wild on either end of the spectrum here. Um, you can get some earthquakes, you can get some fog and stuff, but overall here, not going to get hit with a tornado or anything, luckily. So the rain is usually my friend, usually not going to cause dramatic chaos here. And so, at least yet, until global warming makes the tides raise, because I'm really close to the water. So maybe someday this will be a boat based show. We'll see. Um, but the weather won't get too crazy here. So the main problem I have with the rain is that it makes it harder to film. And that's why in some future grades, I'll try and design, having both an indoor and outdoor set so that I can film even on the rainy days. And last time it rained much was when the desk first broke. So who knows what'll happen this time. got to remind you all that although I call the desk broken, it still looks to me like 90% intact. And often we call things broken once they've lost like 1% of their functionality. But when that desk is even just half broken, I think that'll mean we're only going to see half of it left. So we'll see what's next for the Desk Chronicles. But for now, it does make it a little harder to have gravity not make everything slide into the corner. So thank you to everyone commenting. You are all awesome. And yes, it has already shot past 51,000, which is marvelous and crazy. It's all about the shorts. And this channel, like I've mentioned in streams before, doesn't even meet the requirements to be on the YouTube partner program yet. Even though the main channel is, despite getting millions of views here, because they're not going to start counting shorts for the partner program or for normal monetization of any sort, apart from some weird fund that they have to reach out to you about if they want to put you in, until next year. But that may help me fund the channel next year, be able to make sure I make videos all the time and make them even higher quality. But for now, I'm just making the shorts for fun. And it turned out that the YouTube Shorts and TikTok algorithms both needed a lot of new, crazy, cool math content, I guess. All of the main content on there may have been too dumbed down for people's taste, and maybe the math content on there was too highbrow for people's taste. Maybe they needed something that involved the intelligence, but wasn't afraid to be a little wild with it as well. So they liked my videos, I guess, and keep doing really well. One of them has 4 million views now, where I talk about dividing by zero. And that one has almost 4 million on TikTok, too. For some reason, dividing by zero was the big hit. And so, yeah, I guess I'll just keep riding the wave of the subscribers trickling in, and it'll sink in someday. I've mentioned in streams before that a lot of it still hasn't sunk in, and I went through a lot of crazy things in the past year, including almost dying in January of last year. And not like this last January, but the one in 2021. And so I also had a dark period before that makes me still have trouble feeling the right type of pride or self-love and stuff. But once it sinks in, it'll be pretty awesome having this many subscribers. So it's starting to sink in. And I am so glad that you're joining me on my ride here, because I would be doing some sort of insane project one way or another and dedicating a lot of time to some artistic insane endeavor. But since all of you enjoy learning with me, I'm going to make sure that it remains very educational as well as very chaotic. And I'm having fun putting a lot of time into that. And right now I got just one more scene to film for the next main channel video, where I go into the negative bases that I've discussed on stream. And for people who really have watched a bunch of the streams, for the few of you out there, you may already know some of the topics in it, but it'll be a better explainer and go more in depth of what it really would mean, what are really the abilities and strange superpowers of counting in base -2. Or even base -10. In fact, my favorite of the negative bases would have to be base -6, because I like +6 more. I will give the disclaimer that it's harder to do arithmetic in them, and that I don't suggest that our society switches to base -6. However, I think that everyone who studies math should know about negative bases, because they have weird superpowers and abilities. In fact, I think everyone should know about it, whether or not they care about math, because it's like kind of fundamental thing. How could you count a number? And even in the realm of we're making a certain set of digits, and each place is powers of that digit, even in that realm, there's a lot of wildness to do. So this is about to be the next main channel episode, the negative base one. And I almost was going to just make one episode when I first started researching these topics about insane bases, but now it's going to be at least 3: negative bases, imaginary bases, and fractional slash irrational bases. So those are going to be some wild roller coasters. Um, yeah, that's a fun thing I'm working on. And look, the candles fuse together in a fun way. If I take them out, though, they're all messed up. But they're working pretty well now that the wind's died down. So I can just set them right there. Check it out. Homemade lantern. Berry, wax, wick, lighter, homemade lantern. Maybe I'll do some fire starting tutorials sometime, because the only reason why I haven't been in nature as much for a lot of my videos is that I had all these surgeries this year and a lot of physical difficulty with things. But now that I'm past those surgeries and able to walk again, I'm starting to test out longer hikes and stuff again. And I used to be in love with camping and stuff like that. So it would be cool to teach you guys some survival skills as well. And I'm very much looking forward to bringing some mini whiteboards out into the middle of the woods to teach you guys about some plants and animals. Around here, let's think about some of the plants or animals we could encounter. Well, I saw geese in the sky today, or I heard them honking today, but yesterday I actually saw them honking by, and they were in a really stereotypical V. It was super cool looking, like a V. But the geese are rarer here, and the geese and the turkeys are the really big birds you might see around here occasionally. The turkeys can be by the marina, but you'll see a lot of other birds here. It's a lot of types of bird around here, because down, if you go to the marina direction, you see like cool like herons and storks and stuff, along with just like gulls and things. And then if you go up to the woods, we might see some deer. We might see, could catch some fish possibly. Catch in either sense. Although I'd only want to catch a fish if I could be sure that I would be able to eat it. Not into the idea of hunting just for hunting, but if I was able to actually eat something efficiently, I would consider it. I actually used to be a vegetarian for 5 years when I was a lot younger. And I may take periods of not eating meat again in the future, but right now I do. Right now I'm an omnivore. Let me take a peek at the comments. I've just been ranting while I made sure my candle setup was going good, but I always like taking a stroll through the comments as well. So someone said I've saved them in math. I'm glad to hear that. I haven't even done as many normal like explainer type videos that give you as much of fundamental skills. However, from showing people weird puzzles and things, maybe it does help give them a cool underlying sense of certain things numbers and shapes can do. And then that could help you out in general just by encountering a lot of the weird things that I mention in my videos. You'll find some random test question someday reminiscent of some pattern you've seen. Someone asked how many clocks I have. I've kind of paused on the clock quest, not on purpose. I mean, I haven't no technical official pause. I just haven't gone clock hunting recently because I don't have a budget for clocks right now. If I had a budget, I would just be like going to all the stores in the area and buying one of each type of clock or 5 of each type. But I want variety. I don't just want super cheap ones. I want them to look different. And so I usually go to thrift stores and stuff, or even just find them on the street, or like put ads on Craigslist or Nextdoor stuff. And so I haven't done that recently. But I need to get back on my grind, because right now I want to say I have like 40 clocks or 45, but now it might be up in the high 30s because I've been breaking clocks while filming. So it's going backwards. So most of the clocks I broke are still here in enough of a piece to be considered a clock. But there's been a few clock casualties. So sometimes you go backward in the clock quest graph on your way upward. But I plan on still getting hundreds of clocks like I've promised. So that will come over time, hundreds and hundreds of clocks. So I'm taking a peek at some more of these. Sorry, I can't answer people's specific questions about single math problems. There's so many topics I want to talk about that I can't always go into just one equation. But hopefully, if If you stick with the channel, all your questions will be answered over time. And hello to my fan from India. Much love to you as well. I love when people comment where they're at all across the globe. That's pretty cool. Someday I'll probably do a combo meetup in a park around here, or maybe even in the combo class. We'll see. When the time's right, I'll probably invite some people over to the combo class when the time's right. Right now, my team consists of my friends and family. And so I do need to work on expanding my team further, as well as some fans who I've talked to who have helped me out. So everyone out there is awesome. And one thing I wanted to talk about today was, well, my whiteboard's all the way over there. So, I guess I might want to just get a mini whiteboard going good. Although, how about this first? Let's add a different candle holder. Do I have my unlit candles left? Yeah, one more. Candles and whiteboard markers. Whiteboard gang, down with the chalkboard monarchy. So here we got another perfect candle holder. So this one has more of a problem. It can't like sit as still. It needs to be like resting somehow. Well, this is my umbrella chair, but now that it's not raining, I can move the umbrellas a little bit. All right. And maybe if I set it up right here, it'll stay. Let's see. This is going to melt. Okay, I'll just hold this one. This one will be my personal illuminator. I know that it might not be necessary. I might know it might be visible already, but it won't hurt to have a candle on each side. Also, why don't we let that candle be in the shot a little bit? Oh, man. Okay. Let's see. Well, I'll just give these their own little seat right here. Oh, no. That wasn't intended. Whoa. That was trippy. This like chopped a little bit of a candle off cleanly. Wait, I need the other candles to see this candle. I bet this is gonna start smelling good in a minute, like some cooked pumpkin. Check this out. This must have been melted in a weird way. It like severed it off just by falling. Now there's like a pretty big puddle of wax in there, but if I drop it in, I think it'll be okay. All right. Remember, as usual, my disclaimer. My videos are not recommendations to play with fire or have broken desks or have clocks fall on you. My videos are educational. But it's fun to do captivating visual things as well, and then I trick everyone into learning about math and science. So let's take a peek back here. Yes, Moon Hockey, you can have a shout out. Shout out to Moon Hockey. Subscribe for a while. The real OG fans are the ones who've known the main channel before this channel even existed. But that was even not that long ago. So nobody knew about Combo Class outside of my very close friends and family before April. And that was only people who stumbled across my very early TikToks. And then I started putting them out on my main channel in May, although I'd been filming those for a few months. And then I started putting them on this channel. The first video was posted on September 1st. Wild how recent that was. Sometimes I like to look up the time between days, like I mentioned before, but I was counting my last day thing from when I first started filming any of the footage that made it on this channel, which was when I put out the first TikToks. But that was like I mentioned in a video, happened to be exactly 7 primordial, or the primes multiplied up through 7, amount of days and 7 factorial amount of hours. Um, because I never realized that one, that there's a simple amount of time, which is 30 weeks exactly. Um, that is 7 primordial or amount of days and 7 factorial amount of hours. There are other amazing facts like that. I'll make a whole video compiling them at some point, but I've already made some short videos about really cool ways that factorials show up in timekeeping units. That should have been like 2 or 3 different short videos, because uh, even though our society is pretty dumb with our labeling of a lot of things, some of our time is cut up with pretty divisible good units, like the 24s and 60s. So those 24s and 60s, coupled with the 7 amount of days in a week, which isn't a really divisible thing, but kind of makes up for the other kind of divisible factor you need in these highly composite ones, makes a lot of units of time highly composite numbers. Once you like multiplied those 24s and 60s, and then you get that 7 in the mix from weeks if you convert what you're talking about. So that's a fun hobby of mine, is see how can I turn math I've made into a weird little like analogy or like fact about the way you count a week or count on a clock or something. And there's a lot more clock based ones, because there's a whole Clock Quest series on my main channel, essentially, where some of my episodes will be very clock based and often modular arithmetic, but there are other ways to interpret it too. And there's a lot of crazy patterns in there. A lot of crazy patterns. All right. Someone's wondering what they've gotten themselves into. They've gotten themselves into the combo class. But yeah, the combo class is hard to explain, so they've probably already left anyway. Doesn't matter. Um, and this second candle needs to be relit. Now, like I mentioned, it is forecast to rain in a bit, and I might actually lead the people indoors at some point for a very rare first in my little room stream, um, which could involve me having to first pick a few very important equations, the VIEs, to be able to put on my wall itself. Because if I'm going to start streaming in my room, even though I have some art on one of the walls, another one of the walls that's actually going to be what's behind me doesn't have much on it. So I was like, probably going to need to write some equations on there in addition to this wall. So right now, maybe I'll do a little brainstorm of what are some of the most important equations of all time if I need to put them on my wall. And you may have heard that if you want to get a tattoo, it can be good to like draw the shape on yourself with Sharpie or something and see if you're really down to have it on there for a day or two and how it looks to you after like a day of staring at it. Um, because sometimes if like after a day you're already like, oh man, I wouldn't want to be looking at that for real, then that's a bad sign. um, but I'm going to do a version of that here, where if I write them on the whiteboard, hopefully it'll confirm in my brain like, yeah, I want this on my wall. And then maybe there'll be one or two that once I write them on this whiteboard, I'm like, what am I talking about? I shouldn't write this on my wall. So obviously I need to put oil. Okay, I'm feeling a little sprinkling. So there are kind of 2 steps we could go here. The first step is just, let me put a little umbrella over here so that it doesn't um, get the computer wet. The second step is going to be, all right, now we got a cool little umbrella set up. Or do we? Let's see. Yeah, there we go. We got our umbrella set up. It'll probably slip in like 2 seconds as soon as I'm stop talking. But if it keeps raining a little more, I'm gonna have to relocate to inside, and that'll be a whole nother story. but I think it'll work out. So I guess I don't really have time to test out the whiteboard version of any equations. It's definitely starting to rain. So here's the thing. If I go inside, I'll probably close the stream to make sure I can bring my computer in safely. I might just close my computer. I don't know if that'll close the stream. It probably will. So, um, in that case, you should all come back in 1 second after I close it and rejoin the next rare room stream. It'll just go to a different stream. I'm still going to be hanging out with you guys for a while. So, someone says day 7 of saying they love my videos. Wow, I appreciate it. Must not have seen any of the first 6, but even cooler if you were saying it to people who weren't me. I appreciate whenever anyone helps spread the word of Combo Class. Whether it's loving or even mocking or anything, the word of Combo Class must be spread. Now, don't worry to whoever commented this. If they leave, a curse will not fall upon them because there will be more streams. So at most, it would be a temporary curse. But of course, people will need to leave at discretion. And of course, I should recommend you guys stay. And honestly, what's even extra helpful right now, because I do want this channel to get in the partner program and they don't count shorts, is to watch the older streams. That sounds dumb, but they don't count the live viewer hours for that. But with that said, it's more fun when you're here on the live ones. So even though I want to recommend business wise that it helps me if you watch the older streams or the non-short videos for a lot of minutes, but it's more fun when you're actually here for the live ones. So my actual recommendation is to try and catch them live if you want to have extra fun. However, as time goes on and I have more and more stuff planned that I talk about on stream and things are extra set up here, there's a good chance that I won't be able to interact with the chat quite as much, and I will get carried away like I do now often, even for longer periods. So I don't know what I was meaning by that, but leave all of your random stuff in the chat if you want to chat with me, and I will always continue to stream, but I'll see to what degree I can interact with the chat. Now, what is the channel about? Well, that's a whole long story, but it's about a new way to learn and be excited about learning, and relatively math-based type of fact that is often what we're learning about, but also about the interconnectedness of different fields. Now, I don't want this to just autofocus on that. All right. Hi, camera, come on. Okay. In any case, it stopped raining for a second, so I'll just leave this umbrella right here, even though I'm having to hold it a little bit, and even though now the camera doesn't like my face. But in a little bit, it's probably going to start raining again, and then we're going to have to pause for 5 minutes to start a new stream in my room. And that will actually probably be one of the first times you've ever seen in my room, because I've only had like 1 or 2 short videos that made sense for me to film at my desk. And usually, I spend a lot of time in the combo classroom. But I do have a small room with a bed as well that's, believe it or not, I don't sleep out here. Although it would be kind of cool. What's wrong with the camera? It'd be kind of cool to set up a tent out here and then see what it would be like to spend a few days in the combo class. I want to know like which raccoons and stuff visit out here. Now, sorry it's blurry. I don't know why it's doing that, but it's kind of nice to hang out here a minute before we relocate, so I'm sure it'll be unblurry in the room stream anyway. Now, Wattlife, 3,000 years, says Wattlife has been on this planet, apparently, and that's a new one. But, there are ways of analyzing things where you could say that there may be some ways in which us being alive is not what most would call reincarnation, so I don't really have time to explain my scientific side of it, which I'll go into more in the future. But you could consider all iterations of life that have occurred as similar versions to us that have been happening throughout time. And I want to meet some aliens. That'd be cool. But I often say in my videos, in my streams at least, I'll like look up at the sky and be like, "Thank you, aliens." If any aliens are watching, or any weird simulation creators or gods or anything. And that might sound like it means I am a believer in the conspiracy theory type of alien beliefs, which I'm actually really not. I don't think it's likely that Earth has been visited by intelligent aliens in the past couple hundred years. But with that said, I'm open-minded about a lot of other possibilities, and there's almost definitely alien life somewhere in the universe. So we're not necessarily sure if the life little particles on different planets, like if you zoom out and see those specks, we're not really positive if they are necessarily close enough to ever contact each other or if they're too spread out. But there definitely are other specks out there. Um, so I'm pretty optimistic about the chance that maybe we'll be able to communicate or find with some sort of alien life someday, even if that communication isn't like chatting, even if it's like waving a weird type of colored flag at each other and hoping that they can see it. We'll see. But if any aliens are watching this, you're pretty awesome, probably. Definitely have good taste in what Earth streams they watch. Now, all right, mad scientist. Yes, I believe I have accidentally started becoming one, which I guess is okay. We'll go with the flow. I don't know why my camera is like this. Let's see. You want to zoom in, camera? It just probably doesn't like it being so dark. But that's okay, because now it's starting to rain anyway, so it's getting rather close to that transition to the room stream. Now, yeah, we don't know much about the size of the universe. I mean, we do know what we call the observable universe, but still a lot of questions going on there. And we'll probably find out a lot in the next 10 and 20 years because right now there's been a pretty fast rate of discovery. Now, there are certain things that are myths that they were recently discovered, like humans have known that the Earth was round for a really long time and known the diameter of the Earth for a really long time within a not bad margin. But there are other things about, like, that there was probably a Big Bang and stuff like that that are surprisingly new. In fact, you know what I hope to do someday? I need to get a connection for combo class at just like a few miles from here is the Lawrence Laboratories, where they invented a bunch of elements. I mean, not invented, but they first concocted as humans a bunch of elements. And so there's a bunch of them named after there. There's Berkelium, named after my city. There's Lawrencium, named after the Lawrence Hall of Laboratories and stuff, and Lawrence Hall of Science is affiliated with that as a cool program. And then there's Einsteinium was discovered there, and I think more. So I need to get some hookup in there where they can make some elements for my show. Now, of course, some of the elements they invented are like unbelievably heavy or unbelievably light, or like can only be contained in a microscopic amount in this hyper vial thing, or I don't know the details of this, but there's a lot of them have really weird traits if you look up charts of like their atomic weight or stuff like that. So the man-made ones are probably not that easy to handle, you know. But maybe this lab coat's radiation proof. Who knows? Um, Someone's asking if it's safe to assume that space itself is infinite, and we don't necessarily know. Now, it always seems like one of the great questions of life is that how could there be an edge? Because it seems like there's got to be something beyond every edge, but there's possibilities that things wrap around in a certain way. So my personal philosophy is that if space is not what we would consider infinite, that it has some sort of way. It may be more like a three-dimensional-ish surface of a four-dimensional hypersphere. Theoretically, it could even be like a 4D Mobius strip or something, but that's probably less likely than something spherical. But there's a chance that something could wrap around, and it's hard. You kind of got to define what scale you mean infinite, because maybe you could zoom in too and never hit a boundary. And so in that case, if that's true, then every inch is infinite. So whether we can zoom in or zoom out, it was really interesting when I realized that. You think of like, is the universe infinite? Well, there's kind of a few questions. And this only struck me a few years ago, that it's like you could have infinite in neither direction, infinite in both directions, infinite only zooming outward from where we are, but you'd hit a cellular level at like quarks or whatever, or that it's infinite going inward from where we are, but outward you'd hit some limit. Or maybe it loops. Maybe you go inside and the size loops around. Maybe you zoom in so much and you're back where you started. So maybe it's a fractal. Maybe it looks like you're back where you started, but you're at a copy of where you started. In fact, here's my personal theory. I think part of the infinite, and mostly I'm saving this thought for a video, but since we're on the topic, I'll share it with you guys, which is that my personal philosophy is perhaps like a rock that's so bumpy that if you zoomed in and it kept being bumpy on a rock, it would sort of, the smaller and smaller scale you go, the longer it would take a little ant creature to crawl across the bumpy surface. The more you zoomed in and the smaller you made the ant. It could approach infinity theoretically if you had a like theoretical rock that was infinitely bumpy, like fractally bumpy. Well, you could say that certain fractals like that have like an infinite surface area for in certain ways of measuring it, because it can take, like, depending what scale, it gets bigger and bigger. And so with shapes like that, one of my theories is, what if our universe as we observe it is the 3D bumpy surface of something? So not only is it possibly wrapped around in some way, but we might not even be able to get to the wraparound ever because of how bumpy it is. How many ins and outs might be infinite. So that's not scientifically backed. I'll let you know if I ever get evidence toward that. That's just a weird, crazy hypothesis that I think is fun to imagine. Someone's wondering, why is the square root of -1i? They say, shouldn't there be an actual number? Now, I is an actual number. The thing is that I is on a different dimension than we're used to. Now, negative numbers are not actually that much weirder than I, because to say that something's negative in the world, you kind of have to make it up. You have to be like, there was a direction on something, like a debt or like a downward in gravity or something, to call something negative. So to even refer to something as negative in nature, you have to make an extension for it to be a real thing. Even a positive number, arguably, it's hard to grab the number 3 of a thing and really be like, this is 3. It's hard to see a pi number. Although you could, in my opinion, see things that are said to, as they get more circular, they approach having pi in their equation. But with different numbers, there's levels of abstraction to say this is like 3, a little more abstract to say this is like -3. Now, to actually scientifically use it, you have to trust some hypothetical equations that some scientists think may apply to the world. But it also shows you hidden sides of a lot of graphs and stuff. Functions that we know part of, shows you their inner workings, sort of, a new access to them. And so I is an actual number. it just, and I want to call it, it's a real number, but that sounds misleading. If I ever say that, the R's lowercase, and there is a thing called an uppercase R real numbers. And those are the line that's 0 to positive or to negative, or to what you could call toward infinity or toward negative infinity. And then on that real number line, there is no answer that if you multiply it by itself gives you -1. -1 gives you 1 if you multiply it by itself, because you have two minus signs, two ones and two minus signs. The ones give you a 1, the two minus signs essentially cancel out, make you reverse direction twice, essentially. So similar to how a negative number is an extension that we make up because it's helpful to represent not only ways to maybe define the world, but also just to have a trait of a number that if you square it, you're positive, but it itself or its cubes or stuff are there. Every other power you put it to bounces it, the negative number, to positive or negative. Now, numbers like I have a four-way bounce, sort of, where if I multiply something by I, like let's say I multiply the number 3 by I a bunch of times, then it's going to be like 3I. Then when I hit it with another I, the two I's become a -1 by multiplying together. So then it's -3. Hit it with another I, we're at -3I. Hit it with another I, and it ends up all canceling back to 3. And so you get a four-way bounce with imaginary numbers. Now, could you have a three-way bounce? You can make things on the unit circle that have a three-way bounce, but they're a little different. So you can have any type of bounce, theoretically, of different amounts of like roots of unity, as they're called. So very interesting to think about imaginary numbers and complex numbers, the combo numbers. And what you want to think of them as is starting with trying with any concept with them, understand an algebraic and geometric side to it. And the first one of that is going to be, let's say y is I to the 4 equal to 1. Well, the algebraic version is that I times I is -1 times I is now -I times I is now negative I times I. The I times I turns to a -1. Now we have -1. We have 1. The geometric reason is because there's this complex plane where the amount of i's is that axis and the real line is going this way. And if I multiply points I, it's sort of hopping them a certain direction, sort of like negative numbers hopped them. And a slightly trickier topic that I'll save for a full video is how if you then raise things to complex powers, like if I go like what's something to the power of 2i or something, or like what's things like that, you have to extend the definition of exponentiation, but mathematicians extended it in a way that works very well. And so when you do that, it can make you essentially rotate. And the gut feeling you could have for that is that if multiplying by I makes it hop around, then powers of I are kind of like some in-between version of that. So it can make you spin around. So that all relates to the easiest visualization of e to the I pi equals -1. The first equation I'll probably write on my wall when we go indoors. Euler's identity. And I would call it Euler's formula, but if you see my new main channel video, you'll know that way too many things are called Euler's formula. I put some clips in from the Wikipedia page that's solely dedicated to list of things named after Euler, and how one of the first sentences there is, in order to not name everything after Euler, we often have to name things after the second person who found them, even though he did find them first. But we already named something like Euler's conjecture or Euler's this. So in that new main channel video, we go into one called the Euler characteristic. Now, for Euler's identity, which is a name for that formula, to make clear that we're not talking about something like the Euler characteristic, which is also a formula, or actually a set of formulas in a way. I only showed a certain example about the 3D case, which also happens to apply to something called planar graphs. But there are other versions. But in the Euler's identity, the way you can use complex numbers to help visualize y is e to the power of I pi equal to -1. Now, don't worry, I'll make a whole video explaining it sometime. So the bit you're just going to have to trust me here is that putting e to the power of certain things like that makes it like makes it like a point is spinning around the unit circle. And the unit circle is a circle with radius 1. From on the complex plane, kind of going through like 1 to the bits that are like a mix of one, a little bit of 1 and a little bit of I, but not a full amount of each, and then I, and then like around there to -1 to -I and back around. So the unit circle, but on the complex plane. Essentially, the reason e to the I pi ends up making -1 is it's sort of like we've shot this one point to rotate a pi-ish amount, and it's not a big shocker that exactly half of the circle was the pi-ish amount, and because like circles are so pi based, so the pi gets us having to like the right point on the circle. The I gets us this sort of spin. The e is just a fundamental number. I'll explain its relationship in a longer video, and that's like dedicated to that. And essentially it flies it over to -1 on the unit circle there. Someone's asking what's my new channel. It's not a new channel, but my main channel actually, because this is the one that blew up more because people love the shorts. But there's one just called Combo Class that has the full episodes, the main official ones that are extra awesome. This channel has the streams and the shorts and some bonus lectures that I just wanted to teach random things that I didn't know if they'd make it a full episode in the future or not. But the main channel is even better than this channel. This one just blows up because of how shorts are these days. But it's okay because both channels are for the Combo Class goal. They're both currently in the Combo School in grade -1. All right, let's see if we got any other ones up here. Someone's saying it's like a z dimension to our typical xy. Well, when I was describing it right now, the complex numbers were like more like this is just the x-axis is numbers, and this is how many eyes they have. So to make a complex number, any single dot on there is just a point, not a point and its result on the function. So unfortunately, to have a complex number like 1 plus I, and to graph it, you'd need 4 dimensions because you'd need 2 points of input and 2 for the output. So you have to make shortcuts and weird other visualizations to show, like, for numbers like 1 point I, what happens when I graph them under some function, because you need 2 axes for the input and for the output. There are cool ways to get around that and make it work pretty visually cool, though. But complex numbers, we will get back into in the future because they're pretty awesome. And I'll make sure that if I write equations on the wall in the room portion of the stream, that Euler's identity will be the first one up. Yeah, someone's recommending some complimentary watches with Numberphile videos and dice videos. Yep. In fact, some of the videos that Numberphile's made about dice that aren't the ones about shapes, but other dice videos are about these things called oh, wait, why'd that go out randomly? These ones about this thing called intransitive dice. And I have my own research on intransitive dice that I might try and email those guys. Not necessarily Brady from Numberphile, but one of the people who presents about those, James Grime, who made his own set of dice. I kind of want to email him to see if he wants to talk about intransitive dice, because I've done some research on what some of the simpler possible sets could be, and different ways of analyzing smaller subsets of all the intransitive dice trios. And don't worry if you don't know what that means, but that's because the videos that I have done some of my own extra cool findings, I often want to still double check them a little more thoroughly before I drop them if there's stuff I can't double check online because I found them myself. So those videos, I haven't dropped all of yet. Some of the coolest ideas that are lurking of sequences I've designed. Or, for example, me explaining intransitive dice and my own visualizations for them and some that I've found. But they were also probably talking about the Numberphile shapes video, because I'm not positive, but I think they have made ones about the Platonic solids at least. And a lot of math channels have mentioned the Platonic solids in different ways, because they're such fundamental cool shapes, the 5 perfect 3D dice shapes, if you don't count the spiky ones. And also, to everyone who commented on the video, that there's actually 48 polytopes because they watched Jan Misali's video about that. I have seen a few of that creator's videos, and they are cool. So after people mentioned that, I did check out the video. It's good, but it's talking about a lot that I would not call regular polytopes. Still a really cool video, but I wouldn't say there's 48 because it's including ones that require infinite amount of space that are essentially tilings, and also including other ones that are like kind of like compound ones and things. Or I'm not positive if it included the compound ones or not, but so I wouldn't say there's 48. I would say it depends whether you're looking at the spikies or the normals, but I would just go with the regular polytopes being in the third dimension. There are 5 convex and 4 spiky. And those are the ones called polyhedra, because they're 3D. Polytopes is the general term. And polyhedron is singular of polyhedra. I'll have to include that if I make an episode I've been planning for a while, that even though most of my episodes are math, occasionally I've done ones about the alphabet. And not everyone likes those as much, but there are more about the alphabet coming at some point, such as how dumb pluralization is. And there are some absurd examples of pluralization. And one that we'll probably have to mention just because it's so mathematical, even though it's not the dumbest out there, is polyhedron, polyhedra. So there's weird ones like that. Polytope, polytopes. That one follows the normal rule. That'd be funny if you could just like pluralize. Well, maybe S should be a math symbol to mean a variable that's a whole number greater than 1, because then it's like it's plural. So if I said like 101s, it looked like 101s. So maybe that should mean a multiple of 101. Like S is an integer greater than 1. So that's what I think we should use the letter S for in math, even though it's often used to mean sums and sets and a lot of other stuff. Some letters get overused in math. We need to find more mathematical concepts to name after letters. Like, I can't even think of ones that aren't overused practically. We might need to make some more symbols. But really, X takes way too many jobs on. You got to, if you ever have something that you don't need to use an X, you might want to try avoiding the X. I use X's as time signs in a lot of videos to make it clear for more like a wider audience, but you might want to avoid that when possible. Like I don't do that in my personal notes, and you might want to sometimes use variables that are other letters, because X has so many jobs you'll find being asked of it. there will be like almost guaranteed, if you're working on some complex math thing, that somewhere you're gonna like basically have to call something X. And so like if you ever don't have to, don't, because then you'll have it saved for if you do. There are a lot of letters out there. In fact, there are 25 other letters and other symbols too. Um, cac- Cacti. Yeah, cacti is a funny one. Cactus to cacti. A funny one is a lot of people think you got octopus to octopi. However, octopi is not the most scientifically correct term. In fact, there are two separate, used by different scientists at different times. I've seen both used in official sources that aren't octopi that I think are more scientific than it, which are octopuses and octopodes. And that's a cool one. Octopodes. Um, what other things in the English language are stupid? Well, the letter C, the letter X being a letter, it's a good symbol, good shape, but not a good letter. And the letter Q. Those aren't doing anything unique or important. The overall organization of which, how you put an H after S to make it go sh, and after T to go th and stuff, they lined up all the consonants wrong. Like T has a version of it, basically. It's a voiced and unvoiced version of T, D, T, D. And th is a voiced or unvoiced of th. And there's other ones that are linked up wrong too, like ch and k are not the voiced and unvoiced version of each other, but they do have ones that could be paired with them. So, first of all, there are not that many different sounds in the English language. So, we should just have like 30 letters, and C, Q, and X shouldn't be doing what they're currently doing. And then we should add a few more, and we'd have all the sounds that we typically use covered. Or apart from vowels, that's just consonants. Vowels are a whole mess. And even with those, we could just add like 20 symbols and have all of them covered. Or if we're gonna have them do double things, we could clump them up so much better with the voiced versus unvoiced version of consonant sounds. Now, then there's just the language itself. A lot of confusing things about the English language. Lot to complain about there. You'll find that whenever I start talking about numbers, whether I plan to or not, I start going into like a lovey-dovey, obsessed with the world, I think everything's beautiful tone, and all excited and stuff. And whenever I start talking about the English language, I start getting all frustrated and ripping my hair out because, oh, there's plenty to complain about the English language. Um, However, we're stuck in it, so you got to have fun with it when you can. So I still like making puns and using alliteration and stuff because I am stuck in this society. Um, all right. A lot of other alphabet options. Yeah. So there's a lot of cool alphabets that are possible. I used to design my own alphabets as a kid, although I didn't know much about language construction then. So they were mostly like slight changes on the English alphabet with different symbols replacing them. But it was still fun to write stuff in code. I tried at times to write my own dictionary of all the words in a language. I did not get far in that. There's sometimes where I'll be like, for a week or two, I'll get really into one random hobby or whatever on the side of all my video making and writing. And like I'll usually throughout a week, I'll have like some social time, a lot of video making time, some time in nature, some time writing, some time making music, and then I'll have like some random hobby for that week too. And so there'll be like, there's been like weeks of my life where it was like, what if I learned to juggle? And then I like never continued it after a week. And then there's ones where I'll learn a Rubik's Cube and forget it. And then 2 years later, I learn a Rubik's Cube and forget it. And then there's ones where I'll like get into making up card tricks and learning card tricks like every 2 years for a week or two. Now you guys may see more of these phases as I get into them during my streaming era. So you may see more of this happen in real time. Um, Although right now, so much of my time has just been spent on the video making. Um, which will be easier to spend more time on random hobbies as I work on expanding my team and stuff. So I don't have to edit them as much. And then I can also just read an insane amount of math books like I have at some points in my life and rebuild even more and more knowledge. Um, and go clock hunting more. But forget what I was saying about all that. Anyway, long story short, English alphabet, pretty terrible. Numbers, base 10, bad. Numbers in general, good. I mean, base 10 is not the worst choice. I mean, like, to be honest, if we're making like a tier list of possible bases, base 10 goes in B tier because you can have a lot worse than it. But it's not an A tier or S tier base. That's like base 6, 12, binary, maybe balanced ternary, maybe even negative binary, which we'll go into soon on the channel. And I'm not even getting started on the irrational number bases because I want to save that for when I have my episode fully ready about this. And for when I end up inevitably ranting about it on stream the week I'm filming that episode. Someone's asking my least favorite number base, and that's kind of one of those things where like I could make an arbitrarily worse number base. So if I could go as high as I wanted, I could be like, well, base 276 sounds pretty bad. Well, I feel like base 292 might be even worse. Well, what about like base 511? That sounds even worse. Now, some of those may have actually been more divisible than I realized, but my point's you could kind of arbitrarily make a worse base than anyone you were given in terms of functionality if you just found like a number that was like barely, like not quite prime but not a composite in a very notable way, like that was a really big, that would be a bad base. um so there is weird pros to having a prime number for your base, but there's way more pros to having a highly divisible number for your base. Now, there's also pros to minimalism in the base, but not necessarily having as small as binary because, it can help to not need to use as many characters in a string to express a smaller number. In binary, even to express a number like 50, you need a bunch of digits. So, more than that can help. And in fact, there's a thing called the base radix or radix, I don't know, probably radix, that is, measures a certain measure of how well a base can communicate numbers for a size. And you could imagine that, like, if you had tons of characters, you'd need a way to factor in that having a bunch of characters isn't as useful for, like, your computer or society. And if you don't have that many characters, you can imagine it's not as good necessarily to have to do tons of digits unless you're a computer. And so for humans, you may want somewhere in the middle. And the one that maximizes that trait, called the base radix or whatever, would be base E. But although we can't use base E functionally really, and so base 3 maximizes certain traits. And you can also balance base 3 to this thing called base ternary, where you use -1, 0, and 1 as your characters, but they do function as powers of 3 for each one. And you can express numbers that way just fine. So balanced ternary is a good one. Now, so for my least favorite, do you mean my least favorite popular one? Because then base 10, most suggestions are better than it. Even base 8 would be better. Even base 16 or base 4 would probably be better. Base 4 would maybe be like tied with base 10. 8 and 16 would probably be better. 12 would definitely be better. 6 would be, in my opinion, the best. So 10 gets a really pretty bad ranking comparatively, but I mean, probably base 11's worse than 10. It's just not suggested much, so I don't need to roast it. We're going to talk about 11 hours being on a clock for analyzing when you have prime number bases or prime number mods, so that'll be fun. But it's not going to, for our society, make them better than the highly composite bases. The best bases functionality wise under other traits are the highly composite bases. those are the ones that have the best things to do with fractions and decimals and stuff like that. And like what repeats and doesn't have to repeat and stuff. And so if you care about having less repeating decimals and stuff, then I'm pretty sure the best bases would either be base 2, 6, or 30, because those are ones on the superior highly composite list. Or I might be wrong about 30 and it might be 60, either 30 or 60. Those are ones that are superior highly composite, and they have extra good traits about bases. And let me look up the list, because now I'm curious about whether it was 30 or 60, because I know that 60 was used historically as a base by certain societies. 60 sounds kind of inefficient because, like, yeah, I get that 60 is really divisible. That's why base 12 and base 6 are good, but you really want 60 different characters you have to know before your first 2-digit number? You want 60 to be the smallest 2-digit number? Um, so yeah, 60 is the superior highly composite, not 30. So the first superior highly composite are 2, 6, 12, and 60. So those ones are the best ones based on like certain traits. I think one of the main ones being how well they have fractions not need a repeating decimal as often. Because you can imagine that the numbers that act weird under base 10 are the ones that have less factory traits in common with it. Like 5 and 2 are factors of 10. So 0.5 and 0.2 are pretty simple fractions. That's 1/2 and 1/5. They are each other essentially in that sense for 2 and 5. But then if you look at 1/3, 3 doesn't have a factor in common with 10. So 3 is gonna have infinite 3's stringing on. Same with 6 does have one of the factors in common, but it has the bit that's not a factor as well that makes it string onward. Even 1/8 doesn't need an infinite repeating decimal. It's 0.125 in our base, which helps you remember that 125 is an eighth of 1,000. Which is kind of fun, because since 125 is an eighth of 1,000 and 125 is 5 cubed, why does that combine and make sense? Well, because 1,000 is 5 cubed times 2 cubed. So, yeah, so I kind of lost my track. What's my least favorite base? Because I like talking about them, would be 10, I'm saying, because that's the one that needs the roasting, even though I could arbitrarily make a worse base. Actually, yeah, base 1's kind of bad, just like tally marks and stuff. And when someone's asking what's so bad about it, well, 10's just like makes no sense compared to 6. Or 12 has traits 10 doesn't hit, more factorability, but 6 is neater than 12 and cleaner. And 6 is 2 times 3, 10 is 2 times 5. So the bigger you go up in powers of 10, the less for their size divisible they are, because you're getting all these 2's and 5's and no 3's in the mix. They're not threeven. It would make so much more sense if our base could process threeven numbers properly instead of processing multiples of 5 properly. And think like thirds make more sense for a base to process than fifths. Thirds are more fundamental to nature and math. Also, you can see ways it shows up from base 10 has really sloppy fraction to decimal conversions and relatively sloppy times tables. So if you thought the times tables were hard to memorize, they would have been easier in base 6 or 12. And if you thought like your teachers didn't even try and make you memorize how to write the decimal of 1/7, it's like too hard for anyone to try and even learn until high school. It's 6 numbers repeating infinitely. So The fact that almost nobody knows how to write a decimal of 1/7 is why base 10 sucks. One of many reasons. Um, Now, in base 6, fractions look pretty cool. Let's pull up a little chart of base 6 fractions because we'll give a little comparison to base 10. I'm going to probably make a video about this at some point where I'll explain this a lot better. But for right now, I just want to point out how much better the first few fractions are. We'll just go down the first few. So let's say in base 10 versus base 6, we might want to analyze the unit fractions between 1/2 and 1/10. That means unit means the numerator is 1 and the bottom is a whole number. So, and the reason I'm just doing 1 as numerators is because if these are easy versus hard, it's going to make, like if 1/5's easy or hard, it's going to make 2/5, 3/5, 4/5 all relatively similar in easier hardness to what the 1/5 was, for example. So, okay, the number 1/2, very important for a base. Base 10 handles it just fine, 0.5. Base 6 also handles it just fine, 0.3. The number 1/3, next most important for a base to handle, arguably. Base 10 kind of butchers it right off, second off the bat, 0.3333333 forever. Base 6, it's just 0.2. That's pretty cool. You just got 1/2's 0.3, 1/3's 0.2. We'd remember that flip in a split second. How about a fourth? Base 10, you got your good old 0.25. You're like, well, this will probably suck in base 6, right? Nope. Same difficulty, 0.13. 0.13 or 0.25, just as easy when you got used to them. 1/5. This one is where base 10 is going to get its only lead in the stretch we're going to talk about. The only one, not its lead overall. 3 already left it behind. But 1/5 is slightly easier in base 10 because it's a 5e base. If you really, really care about the fact you got 5 digits on your hand, cool. If that's your full extent of your worldview of your universe, then this will come in handy. You get your 0.2. Now, it's a little harder in base 6. You get point infinite ones. So 0.1111111. Not much harder. You do have to put a line over the 1. So it is sloppier. It's like the 0.3. So now we've kind of at this point had, I would say, even. We're tied because 1/2, they were both good. 1/3, base 10 had the infinite 3s, but base 6 was fine. 1/4, they both were medium good. 1/5, base 6 had an infinite string and base 10 was a little neater. So they're tied up to that point. That makes sense. However, even though they're tied up to that point, if you look at where they actually, no, I'm not going to call them tied. You should get more points for how early your fraction is. So 1/3 is more important than 1/5. We're going to give different amounts of points for them. So I don't know the exact point rating system. I'll come with that later. But since 1/3 made base 10 worse on a smaller fraction, I mean, not smaller in size, but smaller in denominator, then that's worse up to that point already. Even though 1/5 sort of was a flip of what 1/3 was. How about 1/6? Well, that in base 6 is going to be good. In base 6, it's just 0.1. So that one, unfortunately for base 10ers, that is 0.16666. You get an infinite amount of 6s, but a normal 1 before it. So that's a little harder to remember. Most people don't know the decimal for 1/6. You definitely would know all the ones up through that if we lived in a base 6 society. It would be so easy because your point infinite ones would be similar to what 1/3 currently is, and all the others in base 6 were so easy. So 1/6 being 0.166666 is when people stop caring if they know the fractions or not. That's like the first one. They're like, well, who cares if I know what 1/6 is? Because it's bad in our base. But 1/6 is useful. It's splitting something in thirds and then splitting those thirds in halves, or other way around, splitting something in halves then thirds. Now 1/7. Base 10, we got 0.142857, all repeating. Base 6, we got 0.05 with the 0.5 repeating. So we got either a 2-number repeating string in base 6 or a 6-number repeating string in base 10. All right, how about 1/8? We got 0.125, 0.043, same amount of digits. They tie on 1/8. How about 1/9? This one might be debatable who you'd say wins this. Base 10 has 0.1 repeating, like infinite ones, and base 6 has 0.04. I think base 6 is better. It has 2 more digits you have to write, but it's not an infinite amount of one of them happening. Don't need to put a line over one. Way easier for a calculator or something to process. So even though it has 0.04 instead of just 0.1111111, base 6 has still got to be better there. 1/10, obviously our base gets that, but it's not that bad in base 6. It's 0.033333 forever. It's like our 1/3 looks like, but with an extra 0. And then you get to other ones. Base 1/11, unfortunately, is kind of bad in base 6. But if you look at the full list, base 6 is so much better. So there's just like a lot of good traits about it. Now, base 6, part of why it works. Oh no, my light went out. Sorry if I didn't even notice that while I was so absorbed in that list. But part of why base 6 works so well is that here's cool traits about 6. 6 is what you get when you multiply the first 3 numbers. And since one of those is 1, it's what you get when you multiply the first 2 primes. It's also what you get if you add the first 3 numbers, which isn't really all the reasons it's good for a base, but it's a fun fact that helps out, which also makes it what you call a perfect number, because those are all its factors are 1, 2, and 3. So that does help it out too. But more importantly, it's a factorial, 1 times 2 times 3. And it's also a product of the first couple of primes. So you could call it a primorial too, because it's 2 times 3. So it's factorial and a primorial and a triangular number. Now, not only is it what you get when you multiply the first 2 primes together, but it's also tucked in between the next 2 primes, 5 and 7. So the first 4 primes, it's like first 2 multiply to the base, so they're factors of it. Next 2 primes are your b minus 1 and your b plus 1 in your base. And those numbers do cool things, the 9 and 11 we currently have. Someone says we go to base 50,400. All right, folks, let's start coming up with symbols. I feel like that would be a fun challenge to think of, is for a given base, how complex would a certain symbol have to be? Like visually, there would be with 50,400 symbols. You couldn't have all the symbols be as simple as like a square, a triangle, an X, or whatever. You would need to have some that were super complicated. So that would be kind of interesting to try and make a weird algorithm of like what could be the inherently got to be at least that complex symbol or type of symbol for a given amount in a base. Or it would be the same for a language, for letters. So, okay, it's starting to rain again. I don't need to worry about this candle. Here's what we're going to do. All 8 of you who are still currently here, I'm going to close this stream. All 7 of you who are still currently here, I'm going to close this stream, go inside because it's starting to rain, and I'll have a new stream open in 5 minutes. And you can check out my room and recommend equations to write on the wall and stuff. So in 5 minutes, there'll be a new stream going on the channel. Hope to see y'all there. Catch you on the next stream in 5. Thank you. And now I got to figure out how to get my computer inside safely.